Testing equipment. If I'm going to check my cooling system to see if it's okay, we talked about the test strips. The other items that are out there, we'll start with the cheapest. This is the cheapest cooling checker you can get. Basically, I'm looking for how cold it gets, which also tells me how the boiling point will go. Costs anywhere from $1 to $3. It's got 5 balls in it. And I'm going to tell you it has 5 balls for a reason. There's one that looks just like this, and it's for batteries. But it only has 4 balls. And if I stick this in a battery and I suck it up, all the balls turn black, and you have to throw it away. So don't use it. If you take a battery one, stick it in the radiator fluid, it screws it up. So this one has 5, and if you look at it, it talks about temperature plus 5 degrees, plus 25, minus 40, minus 50. It actually shows you what the balls mean right on it. So kind of pay attention to that. You just draw some fluid up. However many balls float, you look at the chart and it tells you. Pretty cheap, relatively accurate. The only time this becomes inaccurate is if you actually check your radiator when it's hot or extremely cold. It's designed to be checked at around 70 degrees. So if your radiator is around 70, it's going to be really accurate. Higher or lower, it loses it. This one here is like $12. A little bit more expensive. Draw fluid up. There's an arrow on the top. As long as you have the arrow pointing straight up, then you read the other needle, and it measures the same thing. It's not going to be a whole lot more accurate than this one. You just paid more money for it.
Has to be around 70 degrees on that one?
Yes. If you want to get really accurate, you can pay $200 for this one. This one is temperature compensated, so you don't have to worry about it. You take this, you put a drop of antifreeze on there, and you flip it down. You look at the sun or a light source, and it goes through this as a refractometer. And so it actually reflects in there, and when you look in here, there's a little scale, and it'll be blue. It's supposed to be blue. You'll see a line where it'll be all blue, and then it'll be white. And wherever that line is, that's where the temperature is. And it'll tell you what the freezing point and the boiling point is. This is going to be a lot more accurate for $200 more. So the secret is measured at 70 degrees or around that temperature, and you can save yourself a lot of money. The third one, which is a test strip, tells me that boiling freezing point, but it also tells me the other half of the side of the story, which is what my additive package is doing. And almost as important as how cold does it go will be whether my additives are wore out or not. And so this little test strip here, which I think for $15 I can get 50 test strips. So these packages I got from Tumac. This is before I knew that I could get it somewhere else. And this was $3.84 for 3 test strips. It's kind of an expensive discovery there, and so I think they've come down. This is when they first came on the market, and these are a lot cheaper. I want to talk about air-cooled systems real quick. This is an engine, came off of a rototiller, and customer brought it in because his engine seized up. He was rototilling along and it went, and it stopped. And so we took the cover off to look at it to figure out, what we were going to do with it, and it didn't take very long to figure out what the story is. This engine seized up because it ran low on oil. But is that the reason why it failed? No. Its primary failure was in the cooling system. When you look at this engine, it is so packed with dirt in these cooling fins, you can't even see the cooling fins. And so what happened is, he was operating it. He checked it at the beginning of the spring when he pulled it out of the shop, looked up, plenty of oil, went on rototill, never checked the oil again. And he didn't rototill hardly at all, but because his cooling system was so plugged up, the engine overheated. That caused the oil to evaporate and burn, and it actually turned into molasses. I mean, it just turned into lacquer at the bottom. If you try to take the oil out of here, this looks like honey or something running out, but it's just black. And so basically they just cooked the oil, it ran out of oil and caused it to seize. And so we went ahead and pulled the head off of it and looked at it, and this is what the inside, you can have that back. This is what the inside of it looked like. And so the top of his head is just, I mean, it was starting to burn oil, and a spark plug, I'm amazed the spark plug didn't give out before anything else did. And so it caked in here, and then the cylinder, the fins in here were just nasty. And so his not checking the oil should have been okay if his cooling fins were clean. The amount of hours he put on was basically less than 10 hours, which is a normal interval. You're supposed to change the oil in an air-cooled engine like this every 10 hours. It's not very many hours. And so he didn't put a whole lot more than 10 hours on it, but that wasn't really the problem. His problem was overheating of that cooling system. So you should pull this cover off, steam clean this thing, spray some degreaser on it, and then wash it out. It's really important. If part of these fins get plugged up, and it tends to be underneath this cover that plugs up, you look at the back,
Ooh, gosh.
these fins look fairly open. You're like, those are clean, because you can wash the outside of it off from here. It's the inside that he couldn't see because he never took the cover off. The inside on this side over here, since it's plugged up, as this engine is running, it'll get super hot and it will actually expand out. This side over here stayed cool because it's clean, and it stayed round. So your cylinder actually becomes oblong. Your piston, since it's round and you're in an oblong hole, it starts to lose compression and actually will start scoring on these two sides. As soon as it starts to score, and it will cease. And that's what this one did. So be careful with that. This needs maintenance just like a regular cooling system does.